Hey, Algebra 2, let's look at lesson 4, unit 4, unit 4, lesson 6. Numbers 1 through 3 are going to be the homework for this. In class, let's see, we started to look at having powers written as fractions. In some classes, I did make the connection to it. In other classes, I didn't make the connection to how that connects to what we're doing here. So all right, we have this first problem that we did here, where 1.5 years go by. We find the rate of the decay factor. I keep saying rate of change, but that's for linear stuff. But the decay factor for that amount of time. So in 1.5 years, it changes this much. And then we say, hey, if we had the original rate of the decay factor, and we took that and raised that to 1.5 power, what would the original factor be? If we raise it to that power, we get this decay factor. But so if we take the 1.5 root of 0.512, we get the decay factor for 1 hour. That one's the one that we started off, and then it starts to make a little more sense if we look at ones like this, where it's like, okay, it starts off at 200,000, it has a half-life of 6 years, meaning it loses half its value in 6 years. So this, we can just get that. The decay factor from here to here in 6 years is 0.5. But what would be the decay factor for just 1 year? Well, if we were to take that decay factor, that mystery decay factor, and raise it to the power of 6, it would be equivalent to a half, that same factor that we just got there. But if we're raising it to the 6th power, how do we find this value? Well, we take the 6th root, because something times itself 6 times is equal to 0.5. Find the 6th root of 0.5, and you get the value of b. This is the 1 year decay factor, meaning that it keeps 89% of its value but loses 11%. So if it's losing 11% year after year after year after year, the amount's getting lower. So then 11% of the lower number is now going to be not as much, and then 11% of that is going to be not as much. And so it adds up to being half in 6 years. You lose half of its value in 6 years. And if you keep losing that 11% every year, in another 6 years, it will lose half of its value again. And we'll have $50,000 at year 12, 6 years later in the future. So we started to see this. Now this, if we wanted to find b, so that if we're taking the 6th root of something, one way to undo that is to multiply 6 times 1/6 as a power. That would give us 1. So if we did this to the 1/6 power, that's the same as taking the 6th root. In some of the classes, I overlooked that. I just kind of focused on understanding this. But mathematically, you're going to see in some of the homework problems that we have these powers, and just look at it. 6 years, we think 1/6 power, which is the same as the 6th root. So, all right, that's my little review. Now let's jump into the 3 problems that I asked you to do. So, population of 1,500, insects grows exponentially by a factor of 3 every week. Select all the equivalent representations. P is a function of time in days. Days, week. A week is 7 days. So a day is 1/7 of a week. All right. So we got things to think of here. If we know the decay rate is that it triples, the decay rate, if we take 7 days, ends up being not decay, but the growth factor becomes a factor of 3. It's tripling. Okay, so I used the wrong value here in our b value. Remember, our y equals a b to the x. I got a little bit of time right now, so I am rushing to try and make this video before I run out of time. So I'm sorry that I'm making some simple mistakes. So if we want to find this mystery b value, we know that it's going to be 1,500 times some value raised to a power of t, but t would be days. So if we had 7 days, we would get a growth factor of 3, but what would be the growth factor for just 1 day? Well, if we take, raising this to the 7th power, if we take the 7th root of 3, that's the same as taking 3 and raising it to the 1/7 power. So on our calculator, we can find what this value would be. So 3 to the power of 1/7, I want you to see that that gives us 0.169. So let's use 1.17. 1.17. We could also do the 7th root of 3, and I want you to see that we're going to, oh, again, I'm rushing. We get that same value. This is what I taught you to do in class. Some of you might find it easier to use powers. That's why in the homework, I'm kind of showing you that powers part. Okay, anyway, we look at this, and either way, we get that number. Now, none of these are the answers here. Okay, so how do we interpret these? This value right here is equal to either 3 to the 1/7 power or the 7th root of 3. These answers here, I do see a 3 to the 1/7. So if I do 3 to the 1/7, that gets me this value. These are mathematically equivalent. This one's right. So in the whole scheme of like homework, if you didn't get this problem, didn't understand it because it's expressed differently, it's okay. Which ones of these are equivalent to that one? Well, I could take t times 1/7, and t times 1/7, we would get t over 7 as a power. So this one's also mathematically equivalent to that one. Yeah, and that's it. These two are the ones that are equal to it. I would hope that you at least get how to do this, okay, and how to set that up. So let's look at the next one. The tuition at a public university was $21,000 in 2008. Between 2008 and 2010, that's a 2-year jump. The tuition increased by 15%, and then it continued to grow exponentially. So let's just work with that. So in 2 years, so we have that it starts off with the 21,000. We don't know what the 1-year decay rate would be. We don't know what that would be. So let's see, t for years. But if we took this value, whatever that b value was, and we raised it to the power of 2, we would get a 15% increase, a 1.15. We would get that as our factor. But that would be if we raise it to the power 2. So how do we find this b value? We're going to take the square root, because that's a 2, square root of 1.15. That's relatively nice. So we get our calculator and we type in square root of 1.15, 15% increase, and we get a 7.2% increase, 1.072. Now we're looking at that. The tuition increased by about 7.2% each year. That one is correct. Yep. All right, so what else is going to be correct here? The tuition cost, so B can't be correct. It's not 7.5. We know that's not right. All right. The tuition cost can be defined as this. Oh boy. Yeah. And here's the thing. That one's right, but we didn't really do a lot of focusing in on that, in class. So I'd understand if you didn't know that one was right. So we got C is right, A is right. The tuition cost roughly doubles in 10 years. Well, how do I figure that out? I take my 21,000 times 1.072, and I raise that to the power of 10. And see, does it double? So what would be 21,000 doubled? That'd be about 42,000, and yeah, 42,000. It does roughly double. That one's true. All right, so we get that. Yay. And let's see, E. The tuition cost can be approximated by this function where D represents the decades since 2008. Now, this one's true. We could use a scale factor, a growth factor of 2 if D stands for decades, because we just found that it doubles. There's the 2 every 10 years. So this one could be true. All right, so that takes some investigation. What's the one that you definitely should get? You should have understood that C one. All right, last one. Okay, here's a graph that represents it. Find the values of A and B. We want to get that like G of X equals something times something to the power, all right, to some power. So we look at this and we say, all right, it starts off with 10. That's easy. Okay. We can see that. And then in 1.5, okay, so whatever this value is, this B value, if we raise it to 1.5, the amount of time, what's the factor that it decays by? Well, if we do our new 1.25 divided by the old of 10, that's just a decimal shift. So if we divide it, we're going to get point, so it moves it over 1. So 0.125. So that would be 0.125. That would be the decay factor for 1.5, whatever hours or whatever this is, or days. We want to take, to find B, we want to take the 1.5 root of 0.125. Okay, so we type in that 1.5, the xth root of 0.125. And we get 0.25 is the decay factor every 1 unit of time, whatever this 1 unit is, if it's an hour, a day, a minute, or whatever. That's the decay rate, is that it loses, it actually keeps 1/4 of its value, but loses 75% of its value. All right, folks, that was it. That's the homework. Hoping that this stuff is starting to click together. Our learning target was this ability to take odd amounts of time and work them backwards to find the growth or decay factor for a standard amount of time, like 1 day, 1 hour, 1 year, 1 month, whatever it might be. All right, bye, folks.